All right, so this is going to be a video on how to try to land a job as a quantitative researcher. So if anyone saw my last video, the topic of that was sort of how to best allocate your skills in terms of coding, mathematics, and finance knowledge to land a job in, let's say, quant trading, quant research, and quant dev. And people were asking for sort of a more fine-grained overview of how do you actually do this for one of these things. How do you best study what are the specific resources you would use for these things. And I've recently landed a job as a quant researcher, so I figured now would be a great time to make the quant researcher video. So I've broken this one down into education, self-study, and then interview prep, and we'll go in chronological order: education, self-study, interview. I will say, I'm not doing the cringe thing where I tell you stick around to the end of the video, but a lot of the problem with people who are in the interviewing stage, I think, is mindset. So, if you don't want to watch the whole video, fast forward to the end there if you're struggling with interviews, because I think this section is very important. A lot of people go about the interview process the wrong way. Okay, so we'll start with education, right? It's really no secret that for quant research, the educational demands are very high. It's very, very unlikely nowadays that you will land any sort of a legitimate quant research role with just a bachelor's degree. So I'm going to be focusing on what you select for your advanced degree, whether it be a master's degree or a PhD. Which to suggest there, or which to select there rather, is even a topic in and of itself. So I may make a video on who I think should and shouldn't do a PhD, because I have some pretty strong opinions on that. So if anyone's interested in whether or not to do a PhD for quant, I can make a video on that. Just drop a comment down below. But if you're going to go the master's degree route, I have it broken down into two scenarios. The first scenario is basically for those of you who can get into a top tier program. If you can get into one of these top 10 programs like a Baruch, Columbia, Cornell, U Chicago, Princeton, if you can get into one of those programs, I think it's a really good option for doing one of these terminal quant masters, like an MFE or an MQF. They all go by sort of different names. There are a lot of different names they go by, but you can use QuantNet, it's a website, to check out the rankings. And again, I think if you cannot get into one of those top 5, top 10 schools, then I would not do a terminal quant masters. The only exception being if you have a specific school that places people really well into, I don't know, say there's some school in Texas that places people into energy trading roles very well, and you want to do that, then okay, maybe that's an exception. But the rule of thumb is if you're not in a top school, don't do one of these quant masters. I think you will not get your money's worth. Okay, no, so for those of you who can't, I think honestly, and this is where I would have been at the end of my bachelor's degree, I would not have made it into one of those top quant programs. So I think most people towards the end of their bachelor's will probably find themselves in this stage. So really what I would recommend is just get into the best school you can for a more traditional degree program. The reason being, you kind of need to hedge your bets now. Nobody knows what the quant market is going to look like in a couple of years. There are a lot of people right now trying to break into quant. And does that accelerate? Does that bubble sort of pop and it becomes a bit easier in a few years? Who knows? So I would really recommend you do a more traditional program that's going to be transferable maybe to some other high-paying job if quant doesn't pan out for you. And so in terms of degree selection, I think the top degrees are going to be stats and applied math for obvious reasons, right? What does a quant do? They do some statistics and they do some applied math, right? A quant researcher specifically. Other acceptable degrees are going to be things like mathematics, like a pure math degree. It's not as good as applied math for obvious reasons, but it's still pretty good. Computer science, same story. And machine learning, AI, these kind of programs. Again, good, but maybe not ideal. Stats and applied math. If you are not at the stage of selecting, and you're in one of these degrees, it's okay. But, if you're thinking about what to do next, I really would strongly advise you do one of these. So these are kind of top tier. These are acceptable, and these are doable. You can make it work if you're already in the program. You're going to graduate soon or something. but they are not ideal. A lot of people will tell you physics is like a sick way to get into quant. I have a physics PhD, and it was very hard to get a job. So think twice about doing a degree like this if your goal is to get into quant. People often want to do everything but quant to get into quant for some reason. Don't fall into this trap, I would recommend. Engineering, similar thing. Mechie, chemical engineering, electrical engineering, computer engineering. They're good degrees, and you can probably break into quant with them, but it's not ideal if you're at the outset and you still get to pick what you want to do. Same thing with like a data science. So again, focus on stats and applied math if you have the benefit of being at that stage in your educational career. If not, you can swing these, but you might have to do some extra work, which I'll talk about in the self-study section. Okay, so in terms of the PhD route, if you do a PhD, again, I think most people probably should not do a PhD if you're trying to break into quant. But again, if you're dead set on it, here's what I would do. I would select from those same degrees, stats and applied math, followed by math CSML, followed by physics, engineering, data science, this kind of stuff. There are some quant finance PhDs, but I don't know enough about them to recommend them, honestly. So again, I would sort of use with caution. I think if you're investing this long into a PhD, I think a more general and transferable skill set is going to be better, just in terms of kind of risk management. A couple of notes about the PhD. Again, I'm not going to go into it deep in this video. I could do a video on it in the future, but it's really not advisable if you don't enjoy research. If you're doing quant research, though, you should enjoy research because it is fundamentally a research job, right? So if you don't enjoy research for the sake of research, you just want a high-paying job, don't do a PhD. Likewise, the subject of the PhD doesn't really matter as much as the thesis topic. So I mean, the name of your PhD might be a PhD in physics, but it's what you do in your thesis that matters much more for transitioning out of a PhD. Because a PhD is fundamentally a research degree, a master's degree is a coursework degree. So the name on a master's matters much more than on a PhD. And here's kind of like an example. If you're doing some, control theory or optimal control or, stochastic forecasting on time series in an engineering department, that's going to be infinitely better for breaking into quant than something like compiler design in a CS department. Again, maybe this would be good for quant dev, but this video is about quant research. So focus on working things into your PhD that will look good to people who want you to do quant research for them. And you have to really weigh the 3-year differential here. This is super important. A PhD is going to be, let's say you're from the US and you're starting a PhD after a bachelor's. It's going to be 5 to 7 years of 25 to 50 grand salary. But the benefit is, of course, that you will get free school and your sort of tuition is paid for. You get a stipend to live on. It's not much, but it's something. The cost of a master's is that, the whole degree might cost you, let's say, 60 to 120 grand, depending on where you go, especially some of those top-tier quant finance masters. They're very expensive. But, of course, it's only 2 years, so there's a large opportunity cost here, and you really need to weigh that for yourself, where you are in your life, where you are in terms of location. You really need to think about things like your family life, when do you want to get married, have kids, this kind of stuff. People don't think about this when they're in the outset of a PhD, but it's wise to think pretty deeply about, do you want to commit 5 to 7 years of your life to doing a PhD? It sounds very fancy and fun, but you can find yourself 3 years in and you're like, oh, I wish I didn't do this. So just really think deeply about that before you decide. Now, what to do once you're in school. This applies to advanced degrees and undergrad. So for those of you who are still in undergrad, all of this still applies to you as well. So network, this is self-explanatory. People did not like this in the last video, interestingly. And I think it's very common for technical people. You want your technical skills to just speak for themselves and, get you your job, right? But that's unfortunately or fortunately not the way the world works. So if you use this to your advantage, it can be very useful, right? It can mean maybe it can even make up for some technical skills, but not all of them, of course. But if you don't do this at all, it will really hurt you. Talk to most people in a job that you want to land. A lot of them knew someone before they got in. You can make cold applying work and stuff, but if you can network, use it to your favor. Competitions and clubs. So this is a long topic, and I'm not going to go in any depth about what competitions to do. You can do the research for yourself, things like Putnam. All of this, that's for, I think, undergrads, but do research here. Where can you get into like competitive clubs, where you can get into math competitions, coding competitions? These things are looked at pretty highly if you score, in some high percentile for them. So I would take this pretty seriously. And I should note that this section is not in any order, right? So I'm not saying networking is more important than clubs or anything like that. It is, but not by virtue of the order of this list. So the third point, again, do your research here, but the third point is going to be you have to take your coursework seriously. This is specific to research, I would argue. You have to balance two things. Short-term understanding and sort of like grades come into conflict with one another. So when you're in a complicated class, say you're taking partial differential equations, at the same time you're taking if you're in physics, maybe some quantum mechanics class and some electricity and magnetism class. That's really heavy coursework, and it's difficult to do that all at the same time. So you have to sometimes sacrifice in the short term understanding for grades. And if you're like for me, I was not smart enough to have some great understanding of the coursework material by the time the exam rolled around. So I had to sometimes sacrifice and just do rote memorization, whatever it takes. And you need to be honest with yourself about your aptitude. So I realized this quickly about myself. Like, I'm not the person who can learn this complex material in a couple weeks and just understand it and go into the exam like that. So in the short term, memorize, cram, and you really have to do whatever it takes to get your, the best grade possible, even if it comes at the cost of understanding. But in the long term, what people are going to be testing you for in like an interview is how well you understand the material. So if you had to use these kind of tactics of memorizing, looking at one thing I was good at was looking at the professor's notes and really sort of guessing what test questions would be on there. And then you study for those. If you're good at that kind of a thing, that's fine, and you will get good grades that way, but you won't understand anything. I can fully say there are some classes I got an A in that I didn't understand at all. And so in the long term, you have to go back and fill in this knowledge gap, or you will be, you will rightfully feel kind of imposter syndrome when you graduate, because you sort of gamed the grading system. Gaming the grading system is fine, if you do it ethically. I'm not saying to cheat, but if you use these like legitimate tactics to game the grading system, that's good. But people are going to expect you to understand the thing that you have a degree in. So you have to go back and fill in that knowledge. It's very important. And sort of related to this is you have to understand the fundamentals. So you do not want to be this person who has like this 4 billion parameter transformer model on their GitHub, and then someone talks to you about a very basic question regarding linear regression, and you don't even know the answer. So you have to avoid this flavor of the month hype nonsense. And it's so tempting because you will see your friends with crazy resumes where they're doing some fine tuning on some large LLM, and large LLM is, I guess, redundant, but they're doing fine tuning on some LLM for some super fancy sounding application, right? I know it's hard, but you really have to resist the urge to spend your time on this kind of stuff. It's so much more important to understand the basics over, doing things like this, having these huge models on your resume, doing some fancy LSTM stock price prediction. Don't do that. Just show that you understand these types of things, the foundations of your field very well. And then from there, it's easy to build up to these more complex applications. But I promise you, your resume will not look as flashy, but people who know what they're doing when they're looking at your resume, they will see this and say, oh, okay, this guy knows what he's talking about. So this kind of leads into the next thing. You have to not be one of these like GBT-brained 20-year-olds. So many people, and even people I've been working with lately, they will write code and send it to you, and you're like, what's, what are you doing? Like, what are you doing here? And they say, I don't know, GPT wrote it. Like, this is such an unacceptable way to go about your daily working life. And so use these tools, but use them to aid in the learning process. Don't use them to circumvent the learning process. So learning faster or in a way that feels more convenient, it almost always maps one-to-one with learning less or learning at a more shallow level. Part of what makes you learn something and really remember it for the long term is struggling through it. So struggle on your homeworks for multiple hours before you ask GPT or your friends or the professor. It's really the struggle that makes things click in the long term. So many people are looking for shortcuts in the educational process, and it's so easy to spot for someone who, really goes through and learns things fundamentally and has a good grasp of the fundamentals and basics. You can spot these people out a mile away in a 5-minute conversation, and you will get rolled in the interview process if you do this. So again, if you need to do it for grades and things like this, that's okay, but you have to go back and fill in the blanks. Now, 6, and most important and most overlooked, is do research. Research is in and of itself a skill that I guarantee you need a lot of practice on. Sometimes the hardest thing associated with research is selecting a problem which is worth solving but also solvable. It's very easy to come up with a problem that's worth solving, and it's very easy to come up with a problem that's solvable. But the overlap in these two sets of problems is very narrow, and a good researcher is good at picking out those kinds of problems. And the only way you do this is by, iteration. So do research, look at quant finance papers, look how you can critique the assumptions, extend the ideas, read what the authors suggest is like a useful path forward. And this is how I recommend you build your personal projects if you want to get into quant research. And so, of course, if you're in an advanced degree, you can work this into your the research part of your degree. If you're an undergrad, maybe you can do undergrad research, or you can, of course, work these things at any stage in your career into personal projects. But that will do it for the education section. Let's go into the self-study section. So the majority of people are not going to be coming from a program like an MFE, I think. And if you're not, you're going to have a lot of self-study to do in order to learn the tools of the trade that are relevant to quant. So the first and most important thing is a lot of people ask, it's like an undergrad asking, what quant finance subject, topics should I get into? Should I get into like advanced derivatives pricing? And they're in like Calc 1. And, I like the ambition, but the reality is that you need, the barrier to entry for quant is very high in terms of technical skill. So and this is true for quant research in particular, the basics, quote unquote, the basics that you need are very, out of reach for a lot of people at their current stage. So here are what I would consider to be the basics. And if you do not have a good grasp on these topics, I wouldn't even recommend thinking about quant-specific topics yet, unless it's in a personal project or something like that. So it's going to be like your Calc 1, Calc 2, multivariable/vector calculus, diffEQ, and then you probably want to have some familiarity with partial differential equations. Of course, you need combinatorics and basic probability and statistics. That's important. Linear algebra, and then also some computer programming. Maybe not, you don't need to know like some high-performance computing framework to, speed up massively parallel calculations, but, you need to be able to code a bit. Make plots with coding, do data analysis, data wrangling. And so that sort of leads me to this next thing. So if you don't have a good grasp on these, do these before you try and get into any fancy quant stuff. It's similar to the person who does the transformer model but doesn't understand linear regression or, gradient descent or something. So here are the topics that if you have these down, you will likely need to fill in on in order to get your quant job. And this you need to pick and choose depending on what type of quant job you're looking for, or what type of quant research role you're looking for. Are you looking for something on the buy side, on the sell side? Do your research there. So it's going to be time series analysis. This is kind of obvious, but a lot of people don't see this in any degree, right? So I'll show some resources down here for all of these. Probability and statistics. I know I didn't have a class in this, right? So I had to fill in the blanks there. Coding. A lot of pure math people won't see coding. Stochastic calculus and DiffEq. Maybe some people from a more statistics background won't deal with these. I don't know. Maybe they do, but it's important depending on what type of research you're trying to get into, especially the stochastic calculus side of this. You can sort of think of these as like the continuous time and discrete time versions of one another. Then you have data science and ML. You need to know some of this nowadays. Pretty much everyone needs to know some of it. Optimization and numerical methods are important to know. Could you implement gradient descent? Could you explain Newton's method, this kind of stuff. And of course, you need to know a bit about your target finance area. You don't necessarily need to know the most for quant research jobs, but you need to know some. Now I'm going to go through the best resources for these, so you can kind of skip around and see what you're interested in depending on the topics above that you feel for you specifically you need to fill in on. Calc 1 to 3 and DiffEqs and PDEs, I don't really have any recommendations. Like, this is such general knowledge for people entering into these advanced STEM degrees that there are a million resources. Just pick one that you like and learn it well. I don't really think there's a big difference between some top tier book like Spivak versus some random book written by your professor. But in terms of these other topics, I think there are some better options than some of the ones that are recommended. So for probability and statistics, I think this book by Blitzstein and Huang is excellent. If you can get through the first 5 chapters of this book, that will set you up for pretty much any quant problem that you will see in the interview process, provided that you do a lot of practice problems. So it goes over combinatorics, probability, the different discrete and continuous distributions, expectation values, conditional expectation, all this kind of stuff that you need to have a very, very good grasp on. And if you don't, if any of those words sound, unfamiliar to you, then trust me, you need this book if you want to break into quant. Now, in terms of time series analysis and difference equations, as well as stochastic calculus, right? So these 3 I kind of bunch together because fundamentally stochastic calculus, like, yes, it's a branch in and of itself, but it's almost always applied to time series, right? It's applied to other things too, of course, but in the context of finance, it's usually time series. So this is kind of like discrete and continuous time series. I would recommend for difference equations, this applied econometric time series book is really good. Goes over, difference equations. Most people haven't seen difference equations. Like, this is not the same thing as differential equations, right? These are discrete versions of those. And how do you solve them? Similar to how you would see in a differential equations class. There are different solutions you guess, and depending on the form, you solve for homogeneous and inhomogeneous case. This is a great book for that. There's also Valery Minokin's new time series book. Seems really nice. It's not out yet, but I would keep an eye on that. I think he has it on Gumroad. And then there's it's called Mastering Modern Time Series Forecasting. And then for stochastic calculus, I think the first version of this book I wouldn't really recommend the most unless you're very interested in like American options pricing. It goes pretty deep into the binomial pricing model, but the continuous time model is where you learn your stochastic calculus. It will introduce you to things like sigma algebras, filtrations, integrating with respect to things like Brownian motion, which is sort of the defining characteristic as stochastic calc. So good books here. They will take a long time to get through those, so start these early. Now, in terms of coding, I'm not a big book person for coding. I've never actually sat down and read a coding book. I just don't think they're as useful as learning on your own and from documentation. But 2 books that I think are pretty good, which I have looked through. C++ for financial engineers. You probably don't need this if you're getting into quant research, honestly, but it's a good overview to, let's say, object-oriented programming in Python, or rather in C++, which is, a lot of the same concepts are applicable in Python, at least the non-niche ones. And then Python for data analysis. If you're totally new to data analysis, using code, I think this is a good book for you. It introduces you to some of sort of the scientific Python libraries and whatnot. But again, I don't really think that books are the way to go here. I think language docs and API docs are your best friends and much better than textbooks. So I would recommend you use those. But there's also a lot of value in free online courses. So the Primeagen, if you've seen him, he's like a software dev, worked at Google or something, or Netflix actually. And he has a algorithms, data structures and algorithms course that's very good. So you can find a lot of value in these. You can find your own specific to what you need, but just I recommend more online resources than sitting down and reading a book from 10 years ago. And you need to learn a lot of coding, but it's a big topic, so I don't have time to get into everything you need to know here. But those are some resources I recommend. Now, in terms of finance topics, usually if you're landing like a legitimate research job, they're going to be okay with you learning a lot of this on the job. But in my opinion, learning your basics on learning the basics on your own time is a good idea, because it will buy you a lot of time once you're in the job to, hopefully impress people. And, you want to make a good first impression. You don't want to be like the guy who walks in with no idea what's going on, but you're smart. That can come off as very arrogant. So I would recommend you learn some of the finance on your own, at least the basics. And I have a few recommendations. This is too niche, right? There are a lot of different areas of finance, but if you're in, let's say, like buy-side things, and you're going to be dealing with derivatives of, equities or futures, things like this, then option volatility and pricing is okay. I think it's not great for researchers because it's not math-heavy enough. I would recommend this, Options, Futures, and Other Derivatives by John C. Hull. Has much more mathematical rigor. It's still very approachable. It's not very hard to get through. So on the buy side, I would recommend a book like this. On the sell side, or if you're going to be doing some fixed income, I would recommend this book because I think a lot of people have an idea of derivatives and things, especially people interested in quant, but far more people don't know anything about fixed income. So this is a really good introductory book for fixed income. And then in terms of data science and ML, Advances in Financial Machine Learning by DePrado is good, but it's like trite at this point. Almost everyone recommends it. It's a good book, but everyone's sort of doing the techniques from it at this point. So it is good. I would recommend you read it if you have some ML background. But an underrated thing to look through are people's PhD theses. It's super important to read through people's PhD theses because you get, and ideally somewhat recent ones or foundational ones, not these middle ground like 5 to 6 year old ones. But this is what I would recommend you do more often than not, because they usually are very approachable. They have a solid self-contained introduction, and they will introduce you to the relevant topics, and you'll get a lot out of this, and you'll get a lot out of how it's at least applied in academia, which will be not one-to-one with what you'll see in a quant research firm, but it'll be somewhat close, right? Because you are fundamentally doing research. All right, but that wraps it up for, what did I do? That wraps it up for this self-study aspect of it. And now we get into the big part, which is the interview process. Quant researcher interviews are very broad in scope, and they are extremely difficult to cover up any sort of lack of knowledge that you may have. So if you just don't understand time series at all, it's going to come up probably in a quant research interview. And because it's hard to cover up these lacks of, domain knowledge, the problem is you kind of need to be somewhat good at everything. So these QR interview processes can be very long. So I was in multiple that went more than 4 rounds of technical interviews, and it's very stressful. Okay, but here are the topics that you need to know cold: probability and statistics. You need to know all of the standard distributions, the continuous and discrete distributions, their expectation values, their variances. I had all of these memorized so that you can answer those kinds of questions pretty much on the fly. You need to know mathematics because people will ask you these kind of Olympiad style questions a lot. And you also need to know coding in the context of like scientific applications. So There will be some LeetCode style data structures algorithms questions, but more so it'll be things like numerical computing. Like, can you implement finite difference derivative, second derivative? Can you implement solvers for things? Could you implement Newton's method? Do you know different nonlinear solvers? Do you know like a Levenberg-Marquardt approach to solving nonlinear systems of equations? This kind of stuff, it's very important to understand a bit about a lot of this and be able to implement the basics. Like, I would be able to implement derivatives, gradient descent, Newton's method, matrix multiplication, all of that sort of stuff. And then data science is very important. How do you do things like outlier detection? How do you check for how normally distributed a sequence of values is? Stuff like this. You'll want to know a lot about that. So for resources here, this is tough because you want to spend your time on the highest ROI, but what the highest ROI is going to be for each person can vary wildly. Okay, so some people really need to up their coding. Some people are top tier in terms of all this mathy stuff, but they don't know coding at all. And that's tough because it's hard to pick up. But here are the overall things that I would do for the probability side of things and these brain teasers, style questions. Let me do like brain teasers because that's a lot of what it is. The green book, that's what you see here. It's a bit over-recommended in my opinion. I went through some of it, but I didn't find any of it very useful for modern quant research interviews. What I did find useful, and I'm not affiliated with this website, is quantquestions.io. I subscribed to them for a couple months, did a lot of their questions. I was doing, in the beginning, I was doing like 10, 15 questions a day, but, once I got to a more sustainable pace, I was doing, 4 questions on their day, medium and hard. And they're very good. And there's also like brilliant.org you can look into again, but it's sort of up to you. It's very introductory, and I don't think it's the most useful for quants. But if you need help with the basic probability stuff, it's useful. Now, in terms of the math, you can just Google Math Olympiad style questions. And from there, they have them at all different levels, grade levels. So you can sort of assess where you are and, go from there up, right? You want to be able to answer these silly kind of questions, like just gotcha questions almost. It's like, I won't give any examples because I can only think of ones that I had in interviews and I can't give those, but this is not my favorite aspect of the quant research interview process, as you can tell. I was actually pretty good at it, but I think it's sort of silly. But you do need to learn some of them. Now, in terms of coding, I just recommend LeetCode and neetcode.io, not because they will be representative of any of the coding that you'll do in an interview, but because they will, or rather in your actual job. But I do recommend this because it will be representative of the coding that you do in the interview process, not your actual job. So you could see this as a time sink, but oh well. I mean, I would recommend, a lot of people have this weird hatred of LeetCode, but it's kind of like you just grind the thing, you do the thing for a bit, and then you get a good job, right? Just get over it. Grind the LeetCode, get over the hatred of it, and just accept that that is the state of the current interview process. Change it once you get in if you like. Now, miscellaneous, this is an awesome resource, deep-ml.com. It has a bunch of questions like implement matrix multiplication, implement a matrix inversion, all of these ML-style questions and scientific computing questions. It's kind of like LeetCode for that. And this is very useful for quant research interviews, I think. Now here's the final part of the video. So it's been a long video, but I hope that some of you have found it useful. But here is where we will wrap things up. So, let me do this just to keep the formatting consistent. So here are going to be the tips for how I would recommend you actually do the studying process. Consistency is going to be much more important than cramming. In the beginning, I was getting some interviews and I would cram study for like 4 hours a day, 8 hours a day, a few days leading up to the interview. And the problem there is you may do well on that interview, but the information that you're taking in, it does not last. So it really kind of sucks because you just need to redo it every time you take an interview. So do 2 leak code problems a day for a year. That's much more impressive, and you will get much more out of that than doing 15 leak code problems a day for 20 days, or even for 40 days, whatever would equate to the same number of leak code problems. It's going to be better if you do them a few at a time over a long span of time. So just be consistent and do a little bit every day. Being good on the foundations makes this way easier. If you are trying to study for hard problems, for example, I did not do well on the probability and statistics part of my first few interviews. So I realized, look, I just don't know the foundations well enough. I need to sort of be humble, go back, study. I studied this Blitzstein book. I don't know what I've done here, but whatever. You saw the book over there, the red book. Just if you find yourself stuck and having no idea where to go on these problems, you probably don't have the foundations in place to approach the problem, and you need to go back and fix that. Third point is you really need to practice interviewing. Interviewing, much like research, is a skill in and of itself. So I would recommend you apply to your lowest interest and kind of easiest to get callback places first, so that you can use these as almost practice. If you land the job, great. If you don't land the job, oh well, it was just practice for your, the jobs that you really wanted to target. I did this too. I applied to sort of smaller places that I knew I didn't really want to get into before applying to the big places and eventually landing a job at a place I really wanted. So this is kind of a strategy. Now, in terms of this, interviews, a lot of people think, oh, it's purely a technical interview. It's not. Even a technical interview is not a technical interview. It is a technical plus a behavioral interview. So you have to think from the point of view of the interviewer, right? So do you get defensive when you're stuck? A lot of people, when they're stuck and they get offered help, they get sort of snippy, they get an attitude, and it's very hard to conceal this. If that's your personality and you are like that, you have to work on that, because people can sniff this out, and it usually means you're someone no one wants to work with, because you're going to be stuck all the time in your job, and if you have a terrible attitude, it's going to be so annoying to deal with you. 2 is, do you have a bad attitude when you get pressed on something? Maybe you get the right answer in a question, but they press you. They say, what if we change this? Why did you do this part? And a lot of people, again, get very defensive and a bad attitude when this happens. You cannot do this. Be someone who enjoys the process. That's why, a lot of this you can't really change, unfortunately, but I'm recommending that you think about yourself this way and say, if you enjoy solving these problems, this won't be you, right? So if you are like this, maybe quant isn't the thing you want to get into, or maybe you got to get your ego in check, whatever it is. You need to think deeply about it, though. And the third thing is, are you enjoyable to be around when in stressful situations? That's what people are testing as well. So, of course, you need the technical basics, right? That's important. And no amount of good personality can make up for that. But you really need both. So the interview is going to be stressful, but are you still friendly with the interviewer in a professional way? Do you know how to carry yourself? Do you come to the interview dressed nicely, even if it's on Zoom? Are you cordial? Can you carry a conversation? This, again, quants are not robots. They are just people. They want to have fun people to work around. They want to have nice people. They want their co-workers to be nice people that are, easy to get along with. And all of this really boils down to, you just have to think from the perspective of the interviewer. If you were interviewing someone, yeah, you care, you want to know that they can do the job, but you also are like, hey, do I want this person as my next teammate? So when you factor that in and you try and integrate that through all of this, what it basically amounts to is you have to enjoy this whole process. And that's kind of where I'll leave this all out, or I'll leave this all, this video. We'll end it here. This is a ton of stuff, and if your goal is just to get a job, a high-paying job, and you don't enjoy any of these topics, you're going to be miserable. You're not going to study as hard. You're not going to do the extra work to, learn the things that you need to learn that you didn't see in a degree, and you're definitely not going to come across as someone who's fun and enjoyable to be around for the interview process. So all of this to say, if you want to become a quant researcher, yes, it's a long path. It's tough and it's a lot of hard work, but you should enjoy it. If you find yourself not enjoying it, I would strongly recommend you reconsider what you're doing and, try something else. But that will wrap it up for this video. I may make a similar one on quant development, quant trading, or I may make a video on this PhD topic, whether or not to do a PhD. So let me know if you guys have any additional questions or what you're interested in. But that's going to do it for this video. So I'll just say thank you guys very much for watching, and I hope you have a good rest of your day.